Hi, my name is Clayton Hamry, and I'm a graduate student in linguistics at the University at Buffalo. I'm going to tell you a little bit about some of the cultural applications of GIS and some of the work I've been doing on the geography of the Lower Fungom region in northwest Cameroon with other students and professors here at UB. To start out with, let's talk for a moment about what GIS is. GIS can stand for Geographic Information Science or Geographic Information Systems. Geographic Information Systems are tools designed to collect, organize, analyze, and present spatial or geographic data. They're essentially tools for conducting geographic research, and include physical pieces of technology like GPS devices, as well as computer programs used for analysis and mapping. Geographic Information Science refers to the field of study about geographic data structures and how to process geographic data. It's basically the theory behind geographic information systems. So, how do we encode and represent geographic data in a geographic information system? There are two main formats, vector and raster data. Vector data is made up of points that are defined by spatial coordinates. Points can be linked together to form lines, and lines can be linked together to form polygons. A big advantage of vector data is that it's scalable, so you can zoom in or zoom out as much as you want, and it won't lose any detail. Raster data is made up of pixels arranged in a grid, exactly the same as how a digital image is made up of pixels as well. A raster data format is very useful when you want to encode a variable that has a continuous range of values, like elevation or temperature. It's also very useful for satellite imagery. These concepts will come up again in a little bit. The project I've been working on is investigating how language, culture, and geography are linked in Lower Fungom. I'll go over a few ways we've been using GIS to figure out the answer to this question. One big task I've been working on is digitizing the built-up areas of villages in Lower Fungom. When I say built-up areas, I just mean the areas of land where houses and other buildings are located. We're representing these built-up areas as vector data, using polygons, so I've been drawing lines around the built-up areas to form the polygons. These lines aren't the actual boundaries of the villages, though, just the limits of the built-up area. I have been adding boundaries for the quarters within each village. Here's an example of one of the village polygons I've made, representing the built-up extent of the village of Misong. It's actually 3 polygons, one for each quarter. Having these village polygons provides a foundation for future spatial and geographic work in the region. Something else we've been looking at is the subject of visibility. That is, which villages can see each other, and does it matter? One thing we've been wondering is, if you can see someone, or where they live, will you be more accepting of cultural or linguistic influence from them? So, we're wondering if visibility between villages could be connected with patterns of linguistic similarity. And we've been investigating this topic through the method of viewshed analysis. So, what is viewshed analysis? To start off with, a viewshed consists of all areas that can be seen from a particular point. So, how do we find the viewshed of a particular point? We use a viewshed analysis tool, such as the one in the program ArcMap, which is the GIS program that we've been using. A viewshed analysis tool requires a DEM, or a digital elevation model, which is a raster representation of the elevation of a landscape. The point that we want to find the viewshed for, along with the DEM, is our input for the viewshed tool. The elevation of the input point is then compared to the elevation of every other pixel in the DEM. The tool calculates if there is a line of sight from the input point to a given pixel, and if there is, that pixel is part of the viewshed. As an example, I'll calculate a viewshed for a point in the Lower Fungom region using ArcMap. Here's the ArcMap loading screen. Now that ArcMap is open, I've loaded a digital elevation model of the Lower Fungom region. Shades closer to black represent lower elevation, and shades closer to white represent higher elevation. Now I've added a point. I've highlighted it with a red arrow here for you to see better. This point is located in the village of Aba. When calculating the viewshed, You can imagine that you're standing at this point, and you turn all the way around to see everything that's visible around you all the way to the horizon. The Viewshed tool does not take into account that buildings or trees might be blocking your view. It's just about the landforms. Here's the Viewshed tool. Our input raster is our DEM of the Lower Fungom region, and I put in our point. I've also chosen a location where the output file will be saved. I'm leaving the other options how they are. Then I click OK, and after waiting maybe 20 seconds for it to calculate, this is our output. It's another raster. The whole map has been sliced into two categories, visible and not visible. The visible areas can be seen from the input point, so that's our viewshed. If I represent these two categories in a different way, I can see the viewshed overlaid on top of the DEM in bright pink. It's possible to create very sophisticated and aesthetically pleasing visualizations of data in ArcMap, like this one here. This is a 3D representation that I actually created with ArcScene, a program that's part of the same suite as ArcMap. This visualization shows elevation, with higher areas being tan and lower areas being green, and also rivers, which are the thin blue lines, and footpaths, which are the thin brown lines. Blue polygons represent the built-up areas of villages in the region. The red polygon is the village of Cochin, and highlighted in a very pale red is the viewshed of Cochin. Everything in that pale red can be seen from somewhere in Cochin. The blue in the top right corner is simply where the digital elevation model ends. There is no data over there. Another question we've asked is what factors influence the geographic distribution of settlements in Lower Fungom? When people built settlements in Lower Fungom, did they choose where to settle based on elevation, or slope, or distance to streams, or perhaps visibility? Those are a few of the factors we're investigating. Here's one preliminary result that we've found. Some villages in Lower Fungom have outlying quarters or settlements that were established later than the rest of the village. In every such case, the outlying quarter is at least partially within the viewshed of the main village. This appears to suggest that when people wanted to establish an outlying settlement, they chose a place they could already see from where they currently lived. So it seems likely that visibility in viewshed has at least a small impact on the distribution of settlements in Lower Fungom. Here's a map that illustrates what I'm talking about. In the solid darker pink with a white outline is the original extent of the village of Aba, or Old Aba. In the medium pink, that doesn't have an outline, we see the viewshed of Old Aba. So all of the areas that are visible from somewhere within Old Aba. In the lightest pink, with the thin black outline, we see Small Aba, an outlying quarter of Aba that was founded later. It significantly overlaps the viewshed of Old Aba, showing that the inhabitants of Old Aba were able to see that location before they built a settlement there. So that concludes my overview of just some of the topics we've been looking at. To summarize what I've gone over, I just want to say that GIS has many applications for the social sciences, including linguistics, and viewshed analysis is just one of many relevant GIS tools that you may end up using. And thank you for listening.